Okay, another hypothesis test. So we have components, defective components, and an electronics company sells the components to a retailer. They say 0.05% are faulty. The retailer thinks that actually might be a bit more than that, essentially. So X is geometrically, so they test them until they get the first faulty one, and that happens on the 90th component. So it's a probability, 0.05% is 0, 0, 0, 5. So getting a faulty one on the 90th, it's quite soon in really if P is this low. So the null is that P is 0.0005. The alternative is that P is bigger than 0.0005. And then define your parameter. So where P is the probability, a component is defective. So they get one on the 90th. If P is bigger than 0.0005, then you'd be expecting to find a faulty one earlier on in that distribution. And so your tail is going this way. So you want the probability of being in the left-hand tail, which is the probability that X is less than or equal to 90. So you want a result as extreme as 90. Or more extreme, but that's going to the left for this one. That's 1 minus the probability X is bigger than 90, and probability X is bigger than 90 is 0.9995 to the power of 90. It just means that you don't get a defective one on the first 90, and so it will have to come afterwards. If that's not the case, then you have got a defective one in the first 90. That gives you 0.0440, which is a little bit similar to the last example, I think. That's less than 5%. So this result is more unlikely than the significance level. And so I'm accepting the alternative. It's too unlikely to have happened by chance. If you get a result here that's more than the significance level, you would accept the null. And then you need a conclusion in words. So there is sufficient evidence to suggest the percentage of defective components is greater than 0.05%, and then you will expect to get a defective one sooner in your distribution, hence the less than or equal to here.